All right. So here we go. We've got some good stuff, some high-quality living math here. Product rule and quotient rule. Product rule and quotient rule are specifically dealing with a situation where we're dealing with, for product rule, we're dealing with a situation where I've got a function of x multiplied by another function of x. All right? I do not mean 3 times the sine of x, because this is a constant times this. This is not product rule. Okay? 3x times the sine of x. You'll notice it's a function of x times a function of x. That is product rule. X plus 2 times x to the 7th minus 4x to the 5th plus 3x cubed plus 2x squared minus 9. You don't have to product rule that, I suppose. You could multiply the x through everything and then multiply the 2 through everything and then combine like terms. Or you could just use the product rule. It's an x function multiplied by an x function. And the product rule is really weird. Product rule states that if we take the derivative of a product, remember we said a derivative of a sum, that was just the sum of the two derivatives, right? We did the same thing with the difference. We said, oh, the derivative of a difference is the difference of derivatives. That sounds really weird when you say it. But the product rule is not the product of derivatives. The derivative of a product is the first function times the derivative of the second plus the second function times the derivative of the first. Now, this is where you get the first juncture. I can prove that to you, but it's weird. Prove it? Are you sure? You're coming down a very scary rabbit hole. Can't see anyways. Let's go. All right, let's do it. I like it. I like doing these. All right, so where does this come from? If I take the limit as h goes to 0 of the f of x plus h times the g of x plus h, what on earth did I just write there? Something with no numbers. There is not a single number in that problem. What? Yes, this is the limit definition of the derivative being evaluated for f of x times g of x. Okay? And what I need to do is I need to simplify this. Now, what's weird about this is I have no function, so it's not like I can, this is not fx plus fh times gx plus gh. It doesn't work that way, right? We're all good with that. This is all function notation weirdness. Yes? This is find the derivative. This is the derivative with respect to x of the f of x times the g of x. So this is just f of x times g of x. All right? And that's what that equals to here. Boy, it would have been nice to have some whiteboard space. Now I'm going to do something weird. I'm going to add something to this. This is why people don't know how to take on this proof, because it requires you to do something really strange. Now let me ask you, if I leave that there, would that have changed the function at all? Totally, because if I add something to a function that exists, that's bad, right? Because I just increased it. So if I increase something by that, I should also, and this is where you all go, that's stupid, because they're going to cancel each other out, right?
Correct.
Good, that's what I wanted you to say. So check. Why would I do that? That's an excellent question. Here's what I'm going to do. I am going to separate this. I'm going to think of this as the f of x plus h times the g of x plus h over h minus the f of x g of x over h. So I'm going to use that common denominator and split it into, so now I've got 4 fractions. We all good with that?
Yeah.
I'm going to take this fraction. I don't want to do it that way. I want to take the f of x plus h, g of x plus h, And I'm going to take this minus 1, this one right here, and I'm going to bring that over here. So far, so good? Then I'll do it in a slightly different color here. I'm going to take this piece right here, slightly different color. So Oz is back there going, ooh, it turned red. And then I've got this minus f of x, g of x over here, right? I'm going to bring that right here. So far, so good? And what I'm going to do is I'm going to group these. You remember that factor by grouping thing that you learned way back in the day?
Yeah.
That's what we're doing. Check. Limit as h goes to 0. What can you tell me about these terms?
Yeah.
They have an f of x plus h, right?
Correct.
So let's factor that out. And if I do that, that's f of x plus h times and over here, what can I factor out? Whoops, one bracket. Now, if we let h go to 0, f of x plus h becomes if I let h go to 0, this limit hits this and then it hits this. What is the limit as h goes to 0 of g of x plus h minus g of x over h? Isn't that the definition? Isn't that the limit definition of the derivative for g? G of x just stays, right? And what's this? Limit definition of the derivative for f of x. Yes, Nina? What I had to do is it's very similar. So when you did factor by grouping, one of the things you had to do is you had to take that middle term and you had to split it into the two numbers that you wanted it to be, right? So that you could then factor out to make the groups work. Agreed? Imagine in this, my middle number is 0. So essentially what I did is I took a 0 and I broke it up into two pieces that would cancel each other out. I essentially added 0 to the problem. Because I knew what my final answer was supposed to look like, I knew what form I wanted the 0 to look like. And that's the weird thing that you are never going to be asked to show this derivation. Okay? There's no way you'll ever, and I hadn't seen it in, well, a year, because that's the last time I taught this class. And so I had to think about how that worked. But because I knew what I was looking for, I knew I needed to get an f of x plus h times the derivative of the g of x. So I kind of already had an idea of what I was looking for to make it work. This would be considered, this is a non-obvious step. It's a weird step that you wouldn't think of ever doing. Okay? So that's why the derivation is never required, because I know a lot of teachers who have no clue how to do that. And I can do calculus beautifully. I never saw it. I didn't see it until 2 years ago. I was like, oh my God, that's amazing. And I thought it was cool. Because there's something wrong with me. Okay? So that's a derivation of the definition of the derivative, or of the definition of the product rule there from the limit definition of the derivative. In practice, it's not nearly as complicated as what the derivation looks like. It's going to look something like this. Let's say I've got y equals 3x minus 2x squared times 5 plus 4x. I want to find dy dx without using the product rule, and then I'm going to do it with the product rule. So if I wanted to do this without the product rule, what would I have to do? Because I can't just take the derivative of this times this. I have to actually make it into a single thing with just pluses and minuses in between all the terms. Yeah, we'd have to multiply this whole thing out. I'd have to say y is equal to, I'm going to do a different color. What is that? 15x? 15x, whatever. We got plus 12x squared minus 10x squared minus 8x cubed. And you would have to go through, I'm going to rearrange that. So what do we got? Negative 8x cubed plus 2x squared plus 15x. This isn't terrible, so if I wanted to take the derivative of this now, I would say dy dx is that wasn't bad. What's the product rule say? Product rule says that if y is equal to 3x minus 2x squared, that's it. Yeah, we're done. How do you know when you're done? That's a good question. You don't. You just hope. Just pray. I thought my chair was right there. It's not. That was sad. Yeah, when you're doing this, as soon as I've gone through and I've done the power rule to each one of the terms, the question didn't ask me to utilize it, didn't ask for a tangent line, didn't ask for any of that, so I'm done. So if I do this, and if I want to invoke the product rule with this, we would take the first argument, so this would be my f of x, this would be my g of x, right? And I would say that dy dx is going to equal my f of x, 3x minus 2x squared, times my derivative of g of x. So this is f, and then this is g prime. So what would g prime be? Plus g times f prime. So what would g be? Times why is it not putting the minus sign in? And I would leave my answer like that. I'm not going to do anything else. Now it looks gross. That's terrible. It's horrible, right? It's not a very pretty answer. In this problem, would I suggest doing it with the product rule? Probably not. It wasn't necessarily hard to do it. So why did I say don't do the product rule, or why did I say I wouldn't do the product rule here, but up here I said I would use the product rule? Yeah, if I think about this, this is going to give me at least five terms. Actually, probably 6 terms as I get through that whole thing. And that's a minimum of 6. Could give me up to like 12 terms. So then I got to keep track of all those terms, put them in some sort of semblance of order, and then attack the problem. It gets very arduous, and it can be solved a little bit easier using that. Let's take a look at another one. Now in this question, you can't get around the product rule. The product rule is stuck. You have no choice. Why do I have no choice? Which term requires the product rule? Two sine of x? Think so? Bingo. So that is not going to require the product rule. So this part is going to be no product rule. But this one is going to be, can I just multiply the 2x times the x? No. We can't multiply inside a cosine. That stinks. So you're going to have to use the product rule for that. So when I go to do this, if I take the derivative of this, I'm going to get that my dy dx is going to equal, let me try to color code this a little bit. I'm going to do this part in blue, and I'm going to do this part in pink. Yeah, those are different enough. So if I do this problem, I'm going to take It's okay. We'll finish off this problem. I do not have any homework for you. I'll have the answers to the homework for the weekend up tomorrow. I apologize for not asking about that. We'll get to that tomorrow. So you got an extra day. Good job, folks. And I will see you all tomorrow.